Okay, so today we'll switch gear quite a lot actually, now that we're done with Linux, right? So now let's switch over to the main content of basically this semester. We'll go into the quick overview of low level. Why do we need to know these things and how to code in C? All right. So let me ask this question. I think I asked it before. What's a computer? So if you think about it, right? I mean, at the end of the day, I need to be able to compute something, then communicate between each component, communicate between the computer and you, the user. And then I need some storage component, right? I need to be a store file, store your data, right? Physically, when you look at your computer, if you have the microscope, right, you see that it's just a bunch of transistor, capacitor, resistor, wires, and all the electronics that goes into the motherboard, your CPU, the memory, and all your hard disk, all the networking components, everything, right? And we use it to make sure that we move electrons the way we want to move it, right? And somehow that becomes, it gives the computer ability to compute mathematical function, represent things in a way we can mathematically define. For example, we can define an image that consists of multiple color value, right? And when you put the color value for each pixel next to each other, it becomes an actual image on the screen. But those are just number at the end of the day. Those are just number at the end of the day. You can then process an image by manipulating the number. At the end of it, it's a simple math operation that we know, and some of you will love to do, some of you will hate to do, but it's math operation. And we manipulate those data so that it becomes whatever you see nowadays, right? And I'm pretty sure nowadays you will agree that computer is really powerful. But at the end, it's just a bunch of bits, 1 and 0. That somehow will mean something, right? So in modern day computer, you might be using, anyone know what that is? Raspberry Pi? Anyone have them at home? Okay, so how many people here heard about this term called IoT or smart devices? How many of you have the Wi-Fi camera at home, at the garage, looking at the, I don't know, surrounding area? How many of you have the, what's it called? Um, smart light bulb where you can control the lights from your phone? Okay, how about the smart TV? Okay, I think at least that for many of you, you have that at home, right? You can watch Netflix on them. And if you can watch Netflix, what does it mean? I mean, it somehow can run the Netflix app, which means it can somehow run an application, which means it's on a computer, right? Right. But most of the time, you just use the TV to watch something, so it doesn't really have a keyboard input. It doesn't really take it's just like your remote, and that's it. That should be good enough, right? But it's capable of, so actually some of these smart TV, modern day smart TV also come with its own operating system. Some of them is Android. I think LG has its own OS, but they have its own operating system, right? But these are smart devices. Raspberry Pi is a small board that on its own is a full-fledged computer. You can actually install Linux in that thing. They have, you see that there's a bunch of pins here, right? These pins, you can actually connect that to sensors, and you can actually measure things like temperature value. You can measure the distance. For example, you can have the range finder to measure, like, it can read how far is this board to the object you want to identify. You can actually plug in multiple things. It does have this, sorry, the USB and HDMI connection and the Ethernet cable. Okay. I know a friend, for example, who buy this thing and put in the, I think, PS2 emulator. So you can run PS2 games on it, plug it on a TV, and that would work, right? These are the GPU. How many of you here play games? How many of you want a good GPU? Yeah, me too. I do play games as well, right? Why do we need that? For the FPS, right? Frame per second, so that you can play the game without noticing that things are slow. Also, you want to be able to play the game with the max out graphics setting so that it look really, really surreal, right? I mean, imagine games back in like when I was younger, like in high school, right? The game back then is not as good as now. So the hardware changes, the software also changes as well. These are the picture of, I took this picture from the website on one of the supercomputer in the US. The lab is called Lawrence Livermore National Lab. In the US, there's multiple supercomputer across different national labs. This is one of them. As you can see, there's like a bunch of racks. Inside them, there are going to be a bunch of server in them that are running, in many cases, applications that are scientific, like let's model where PM255 today will evolve into in the future in 1 or 2 days, predict weather pattern. Are we going to see more rain? Are we going to see more storm coming? Will we all die because of global warming? Which I guess we might. But anyway, so these are complex mass operation that requires a really, really powerful machine, right? You also on the other end of spectrum, right? Unlike supercomputer, which is not really portable, you can't really move these guys. But the iPhone, that's a really old phone, by the way. Back then still one lens. These are really, really powerful phones. If you use like if you look at the current, that's not the current one, but like this like iPhone, anything more modern than iPhone 10. I can tell you that the compute capability is actually much more complicated and faster than a computer that we used to go to the moon back in the day, in the 70s, right? These are really, really powerful computer. You can also have things like GoPro. What do we use it for? To kind of record all the crazy things you do, right? Then you would design the computer to optimize for things like video processing, image processing, networking, so that you can talk to the internet and upload your video, right? And then to make sure it's cheap enough that you can pair this up with a really good camera. So you would kind of minimize the cost on the computing side, do whatever it has to do, and then make sure that as many people can buy this as possible, make it cheap enough, right? But when you look at all those computers, right, there's a lot of abstraction on the hardware as well, because at the end of the day, what is the one language that we all know right now? Python, right? I assume that everyone in this room know Python. You can probably program in Python across every single machine you've seen earlier. Isn't that nice? It actually makes your life much, much, much simpler, right? You go into the school, you only have to learn the programming language. You don't really have to learn the hardware. And actually, the main focus of basically this program, actually, you would focus most of the time about software, and you would abstract the hardware, because that leads to productivity, right? You would learn algorithm, how to use fancy math operation to do certain things really fast, how to develop new program, how to develop new type of data structure that it store the data in the way you want really quickly, right? How to build a huge database so that it's fast, how to make it reliable, but we are not going to learn too much about the hardware except for this part and basically this part, which is another possible part, how to build the system and how to build the hardware. Why might you want to know this? Because sometimes you might want to also know how does your computer actually run whatever you're running right now, right? If I run the same code on a different machine, why does it work? And why does it not working, right? Why does it not working? When I run Python versus Java versus C++, those are higher level language that can do fancy things quickly. And you also might not want to be able to well, you should be able to write program in C. You might not want to do that all the time. It doesn't really give you a lot of powerful programming language as tools, right? You don't have objects. You can't just randomly use a variable without declaration in C. There's a bunch of restriction. You have to do memory management on your own. So it's a little bit more annoying, but it's also closer to the hardware. So you can control the hardware using this lower level language on the right side of this, like assembly. Machine code, don't worry about that. We are at the age where computer evolved enough that you don't have to worry about machine code, just know it exists. You also don't want to control each transistor individually, right? But that in the end, in reality, is how the computer actually functions. The question is, if I say all these things, why are you guys here? Except for it's a prerequisite for other classes and so that you can finish your CS requirement and graduate, right? So here's why. So what if your code is slow or consume too much energy, like you build an app on your phone and it burned through your battery, right? No one will download that app, right? You switch to a new computer and the code gets slower. And that happened to me before. For example, I think there was some games I want to play. So what I did was I upgraded the GPU to play them. I was expecting that it would be faster. It just happened that it gets slower because certain things are not optimized for the new GPU. So I have to update a lot of other things because your code is now not super compatible with the new GPU, right? And in that case, what I did was I updated the GPU driver, and that helps a lot, right? The program sometimes produce incorrect results. Sometimes it's a bug on the program that's obvious. Sometimes it's a bug that related to certain things on the system, so it's less obvious, right? But as a programmer, you need to be able to fix them. You run into system level bugs. That's actually now it's way more complicated because now you have to kind of know the system enough, know the OS enough so they can tackle and fix your code. Or your code just make computer hands. You might be able to figure out, you should be able to figure out what to do afterward, how to fix it. What is the cost of that? Or I can build a code that would shut down a computer because I use too much of certain resource. That can happen, right? And knowing how the computer really works helps a lot. And actually, it helps a lot more these days because nowadays we don't just program on a CPU alone. In these days, you can program on GPU for AI application, machine learning application, and many data parallel application that are running really fast on a GPU. You can program on a special hardware. And because the hardware gets way more complicated, if you know these things, right? If you know this thing, the ability as a programmer for you guys will improve. So now let me basically let me now talk about this particular example, right? I have a really simple program. Sorry about that, it's in C. I initialize 3 variables, I, j, and k. And the only thing I do is I add I and j, 10 and 20, add them into 30, write the result into k. How many people think this is a simple program? It is, right? The only thing it does is add two numbers. How many people then wonder deeper, which is how do my computer take this and run it? Because it's like, how many people treat this thing as a black box? Once you pass the programming phase, when you hit that run button, somehow everything runs. It becomes like input to a black box, and then everything works. How many people treat computer like a black box right now? Many of you, right? Well, not a lot based on your hands. But at the end of the day, when you look at the problem, right? When you look at a problem, you basically start all the way from user. User is the one that gives you the problem, right? Then you develop the algorithm that hopefully solves the problem in hopefully as efficiently as possible. Then you build the program. And most of the time, what you learn so far, that's it. And for your life, that's it as well. But underneath, there's a compiler. Compiler is responsible for transforming your code into something that computer can run. Then there's a runtime system, which is basically take that program and figure out when to run it. And when it's running, how do I manage all the programs that are all running together? Then you have the ISA. How should I talk to the hardware? Then you have the microarchitecture, which is how do I build the hardware? So this ISA is talking to the hardware, microarchitecture is building the hardware. Then you have physics, logic, device, and electron. And nowadays, it might not be just electrons alone. There's like proposal to use light, and we use it too, right? We use light to communicate now because it's faster than electron. Right? So these are possible. These are all engineering and science and math, right? So from your program, it actually has to go all the way down there to run, right? So another thing is, as I said, in your computer, everything becomes a file, right? Even binary, the program that you execute, they are file. When you run a program, everything becomes data. The OS copy the program code that are in binary where the computer understand that already to the memory. Think about it this way. Let's think your CPU is the brain, and your CPU can only access this one space that contain the program, and that's your main memory. Program is there. All the data that you're running is there. Anything that you need is there. Everything you need is in the memory. So your brain access that. Data is also there. The processor then access the program, start from the first line, keep running, look at the data from the main memory to perform all the computation, right? So let's say you have a program, don't have to care about what's in there, but it's a source code in any different languages. Can someone give me some sample of a language that you've seen before, or you know, or you heard of? Rust, okay, what else? C, Python, Ruby, anything else? Huh? JavaScript, HTML, JavaScript, HTML, yes or no? It's okay, it's okay. C++, right? But these are different programming languages, right? Now, what I want you to take note is somehow they all talk different languages. This guy can run it. How? Imagine this, right? Let's say in this room, there's multiple people and each one of you talk different languages. How do we communicate? How do I talk to you guys right now? In English, right? If I start to talk in Thai, some of you might not understand, right? Think of, let's say, Thai is like one language. French is another language. Japanese is another language. Chinese is another language. And you can program in those languages for sure, but somehow I can talk to the computer, right? So one of the magic behind that is this guy, the compiler. The compiler, one of the main jobs is, first of all, it look at your program, whatever you type in there, then it try to understand what are you trying to do. Then it, think of it different. It then translates your program into the machine language, which by that point, your CPU understands. So think of it this way. Again, this room, we all speak different languages. Then I would say, let's assume the computer talk in English. The compiler, think of it as a translator that would translate that language into English. Now the computer then understand and can follow your command, right? So now if you have, again, this is another really nice tool that abstract away the complexity of how to make sure that every single language, programming language, will run on your computer, right? Then the CPU only have to understand one thing. It can be, for example, if you use Intel or AMD CPU, this will be x86 assembly. If you buy the M1 and M2 chip from Apple, this would be the ARM assembly. If you buy certain other product, it might be another assembly called RISC-V. There's like a few assembly languages that are active nowadays. If you, for example, PlayStation and PlayStation 2, they use another assembly called MIPS, MIPS, which is the ancient version before RISC-V. And there's not a lot of that. Once you have that, right, you have the ability to basically invent any number of languages in the programming language. I can come up with a totally new programming language. Then I build the compiler. So as long as I can translate that to assembly, I'm good. All right. So that's one of the really nice magic that we do. And the compiler job is to make sure, compiler is a program. The program read your code, understand what your code is trying to do, and then translate that to assembly. Awesome question. The one, well, I guess you can use any languages to do that. The common ones built with C++. But yeah, you can, basically it's another program, takes the input, which is your source code, right? You check your source code, it spits out ones and zeros, right? So any program can work as a compiler, as long as the binary generated is understandable by the CPU. And then the other magic is when I look, let's say you buy an Intel CPU or AMD CPU, right? In there, they're gonna have you can download x86 manual. They will tell you if you want to do this, right? The binary, just like the ones and zero have to happen this way, that way, that way, that way. As long as you conform to that thick manual, you're good. Yeah. And again, language has grammar, right? When you write text in English, if it's like, if I say something like he are running, is that unclear? Are we talking about one person or multiple persons? Because I use plural form of the verb or, but then I said he as a subject, right? So am I talking about one guy, or am I talking about multiple people? And that means syntax is not correct, right? So the programming language also has its own syntax. That's why when you write code in Python and when you type in something that the computer doesn't understand, you can say syntax error. because it literally doesn't understand what you want them to do. And that like when you cannot run your code and say there's some, we all use Python, right? You know that when you want to do certain thing, you have to tap. If you don't tap, it will complain. That's syntax error because it treats tab as another code block that it's supposed to do together as a block of things. If you don't have that tab, it's like, I don't know what to do with this. It's unclear to me. All right. Yeah. So the assembly language doesn't really need a compiler. Basically, when you use a compiler, you start from a program in a language of your choice. Then you run the compiler to compile your program into binary, and that binary will follow the assembly language. And once you're there, your CPU know how to do things, and it will follow. Basically, then it will follow exactly as you program them to do. So I guess if you ask the question, will the machine kill all of us? Yeah, if we program them to do so. All right. Any question before we transition to C? So we'll kind of wrap this up. It should take less than 15 or 20 minutes because we're going to have in-class exercise to make sure you install C compiler and you can program in C on your computer. So why C? Again, this is going to be an annoying language, but it's fast. This is one of the really good things about C. Super fast because it doesn't really do a lot. It do exactly what you tell them to do. You have direct control over so many things, including the memory location. Also, another reason why they're fast. You can optimize a lot of things on your own. So if you know how to code well, this is going to be a very fast language. It's minimal and clean. If written well, that's a really big if. If you write it well, it's going to be quite clean. If you don't write it well, it's going to be super messed up. And I did both versions before. If I have to rush, somehow my code is messed up. If I will write to make sure that people can take my code and do something else afterward, I can make sure it's clean. It's compact. When I said it's compact, means that you can do whatever you want quickly and done. This works really well in what I would call embedded processor. The processor, that the microcontroller that goes into this guy, for example. What do I have to do in here? I need to be able to send certain signal. If I hit up, it just has to tell that device increase the temperature. If I hit down, tell that device to decrease temperature. It's simple, right? If there's a signal here, do one thing. If there's a signal here, do one thing. You might be surprised in embedded processor, it's a bunch of if else. Yes.
Is the calculator also printed?
Is the calculator written in C? I guess you can. Depending on the processor. But C is a pretty nice language for many of the resource limited devices. Because when you compile, your program is going to be small as well. And that's huge because this thing doesn't have a lot of memory. It might have like 1 kilobyte of memory or like 16 kilobytes, right? Which means that your code and your data has to fit in here, right? In this day and age, it's not a bigger problem as much anymore for you guys. But when I was coding, like in high school, right, I have to actually think about how much memory have I been using so far. Because if I use too much, my computer doesn't run. Because back then, computers like 512 megabytes of memory. It's not like 8 gigabytes you have right now. And 8 is small these days, right? You're looking at 8 to 16. Why not C? It's annoying. You have to manually manage the dynamic memory. This is something that will haunt you for the entire semester. You're checking your head right? Yeah, but you've seen it before. We'll go over this later. It will be one of the most annoying things that you've seen. It also make YC fast. Do I find this annoying? Yes and no. In another class of functional and parallel computing, we'll learn another language called Rust, which is like also really, really fast, and we don't have to do this. But it comes with another restriction. It's not object-oriented, but you have C++, so it's not a big disadvantage. You just use C++ instead of C. C++ is like C syntax, but Java ability to have objects. There are many ways to create bugs. I'll let you learn through practical assignments. You see that on your own. There's so many ways you can do to have bugs, and you don't have to be that creative to have bugs. Basics. Each line, when you have a statement, when I say statement is something you command, one command that you put to the computer. When you have a command, you end that with semicolon. A small side explanation of why is basically when we define C as a language, right? The compiler have to understand that's one statement followed by another statement. We have to be able to like separate out each statement, right, between each other. And having one symbol to separate those things is convenient. So we say, hey, let's use semicolon to separate out those things. When you declare a function basically determines what your code do. That's the majority of your code will be in some function. There will be a main function. Basically, it's a function literally called main. That will be the first function to run. When you run your program, it will run the first line in the main function. It's just an assumption in C language that it will run the first line in the main function as the first thing when you run the program. Variable can be declared globally or locally. When it's globally declared, it means that I declare and define the variable outside of the function. And when that's done, every single function can access that guy. It has permission to read and write to that guy. A locally defined variable is defined inside the function call. Only that function can access that variable. And similar to Java, function return a value. Think of it as a math function. Take input, spit out some output. It doesn't always have to take input, doesn't always have to return anything, right? The input to the function will have a type. When I said type, it means like, is it an integer, character, floating point? Yeah, that's it. These functions are physically located in the memory. So everything you write in a program, when you run, those are in the memory. If you can write a function this way, int add, int ab. These are the inputs. The inputs will be in the parentheses. So when you declare a function, this is a function name. This is a return type. Again, you need a return type. You need to tell the computer that this function return an integer. This function has a name, add. Inside parentheses, you put in as many data type as you want. Each one are separated by comma. Each one are going to be separated by comma. Data type plus the variable name. That's how you can declare a variable. In this case, there'll be an integer called A and another integer called B. Yes. So let's say this is a function definition, right? And by default, it's going to be declared somewhere in your file, but it's going to be treated globally, which means that everyone can call that function. But A and B are local variable because it's defined inside the function. Only add can access A and B. Now that we have the parentheses for the input, right? The next thing is the function body. Function body starts with a curly bracket, ends with the end curly bracket, and you can put whatever you code in there. if you want to return something, basically when you have the return, it means that I want to create this as an output to my function. I would say return followed by whatever you want to return outside. So in this case, I do a plus b, return that. And again, when you compile a C program, whatever is in the main function will be the first line that gets run. This is the assumption. You will have a function called main. It doesn't have to be returning integer. It can return whatever you want, but in most cases, you would return an integer that tell what's the status of the program. And the classic example is if it's finished, you end with return 0. It means that it exits normally. That would allow you to return some other value in case your program doesn't exit in the normal way, to communicate to the basically to the user that runs the program. All right. It supports multiple data types like integer, character, float. So that's the data type name. You say int A, char B, float C. A, B, and C becomes the variable name that you can use later. So note what this is one of the most common confusion for many of you going forward, which is I know there's a integer, but basically they represent value. What goes in there can be in binary format, in decimal format, whatever format is the value. It has the same value, right? It's like when I write decimal 5, it's going to be equivalent to 101 in binary, right? This is the same value. 101 in binary is 5 in decimal, also 5 in hexadecimal. So I can say int A equals 5, and I want to print them out in binary format. It would basically print out 101. If I want to print 5 in hexadecimal format, it would print 5. So it's the same value. It doesn't mean that they have to store this in what format. In value of 65, for example, if you convert that to a character, it just ASCII table will print out the letter A. Because again, the letter A has the value 65. And C only support basic data type. We will learn about something a little bit more complex in the next lecture. We don't have Boolean. If you want to use false, 0 is good for that. If you want to represent true, non-zero is good for that. So if I say if 0, else, this is the same as if false, blah, 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 blah. So it will go into the else part and run that code. So actually one common mistake that sometimes you might have is, let's say you want to check if A is 0 or not, right? To check if the number equals something or not, you use double equal sign. So if I do if A equals 0, will mean that I would read the value of A, check if that's 0 or not. If it's 0, that's true. If it's not 0, that's false, right? One mistake, I can do this. If A equals 0, what's the difference here? Yes, why? So there are multiple steps here that are going on. A equals 0 means that I want to put the value 0 into A. Because equal is an operator that assigns the value to the right into the variable to the left. So it assigns the value 0 to A. And it just happened that the equal operator returned that value. So it returned what? 0. Become if false. And if I make another similar mistake, but it becomes A equal 1, in that case, it put 1 into A and return 1. Now it becomes if true, right? So be mindful about that. That's why I said, like, you don't have to be that creative to create bugs. Forgot one equal sign, thing behave in a weird way, right? Declaring variable is similar to Java and Python, but you have to explicit. You have to declare that beforehand. In Python, you don't have to do that. In Python, I think you can use variable from the get-go. You don't have to declare that. In C, you cannot. It will not assume that that's going to be a variable. You have to declare that. So you have to declare by int a equals 10 means that I want to create a variable called a that has the value 10. Int b comma c means that I want to create two variables b and c that I can use later. You can assign value from data size to another. So let's say I have a long integer. Long is long integer. It's 8 bytes long rather than 4 bytes. I can do d equals b, and that's okay. That's okay. It will know how to convert and put that into a longer version of integer. You can also force conversion by casting. So let's say you have the variable a that has a type character. For example, right now you have char a equal letter a, right? I say, hey, character called a will have the value letter a. Capital A just happen to be number 65. So if I do int a casting like this, it becomes 65 integer. All right. Another thing that you have to be careful when you do division, integer division throw away all the remainder. So 12 over 5 becomes 2, not 2.4. If you want to get 2.4, cast them into floating points before the division. And you have multiple operators. It's similar to Python and Java. Do a plus b, b plus plus, division, modulo, equal, not equal, less than or equal. So the same logic applies.
So you convert from float to integer.
Uh-huh.
Does it round down or like Python is down?
Great question. Always round down.
Round-
Always round down. So it's 2.9 become 2. Another thing to be careful. All right. So logical operator also work. We're not going to go into much detail here because there's another lecture for this. Oh, actually, no. Logical operator, yes, let's go with this for now. Not means if it's true become false, false become true. And mean and. If A is true, B is true, A and B is true. Or means that only one of them has to be true for the whole thing to be true. Bitwise operator are something we'll talk about later. We're not going to use it now. We'll talk about this in, I think, 3 weeks. These are something that you can do as well. It would treat your number as a binary number and perform a bitwise operation on your variable. You can use double slash for comment. You can use slash store to have a block of comment. This is how you can do say, hey, this answer is inspired by Stack Overflow in this link on your code to tell us in case we found some solution to look similar to something we've seen before a lot of time. You can use if, else if, and else, and switch case. We'll do more practice next week once we do a much more full-blown practice on C. All right, but that's also an option. You can do if else.
Give a semicolon for that comment.
Where?
It's an import.
Oh, here, right?
Yes.
This is a comment.
So do we need a semicolon for it or we can just write without it? Like Python, you can just write it from in like half of it.
Oh, so every statement needs a semicolon. So the semicolon is needed for this guy. Yeah. And the way switch case work is you first start with switch. This is what you want to test with. So we are testing the value of A. Then you just do cast for each of the cast. Cast 1 means that if A is 1, do this. If A is 2, do this. You will notice there's a break in some cases. So what switch case do is, let's say in this case it's 1, it would do B++. and will not stop. It will keep doing whatever is tell. Like it wouldn't go into case 2. It will stop only when it sees break. So in this case, if A is 1, it will do B plus plus. It will then go into case 2, do B plus plus again, then stop. If A is 2, it will do only just B plus plus for its case and stop. If A is not 1 or 2, it go to default. If it doesn't match any of the case you put in, go to default. Oh, plus plus is increment. So let's say B is 2, right? B plus plus makes it 3. You can also do B minus minus. This is decrement. You can also do plus plus B. Again, make it 3. But plus plus will do it at the end. So let's say you have a statement that has multiple operations and you have something that's plus plus is done at the end. Plus plus, the B plus plus is done at the end. Plus plus B done first before you finish the rest of the statement. It's just the order when you do things. For example, let's say C equal B plus 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 1. I would do B plus 1 and then increment B. If I do C equal plus plus B plus 1, I would increment B, then add 1 to that, put that in C.
How does it increment?
What do you mean?
Increment by 2, 4, 5.
Oh, no, plus plus only increment by 1, always by 1. Yes. If you want to increment by 2, you can do this. B equals B plus 2. You can do short form. If it's B equal B plus 2, you can do B plus equal 2. That's kind of like a short form for B equals B plus that number. So B plus equal N will be B equals B plus N. Loop for loop. The first thing in the parenthesis, initially I would do this. The second thing, then I'll keep checking if I is less than N. If it's less than N, I'll keep looping around. Then the last thing is when I finish one loop, what do I do? Increment I in this case. While loop, do while loop works the same way. While something, if the statement is true, keep doing this. Do while is something like this. You can write do. It will keep doing this part until the statement in the while is not true. Because as the name suggests, do this while statement is true. You can also use break to break out of the loop right away. You can use continue. It's not breaking out of the loop, but stop that iteration, go to the next iteration. All right, one more quick thing. In C language, there's this thing called header file. Header file. What it is these are predefined functions that you can use for your convenience. For example, if you want to print something, print function is called printf. And inside here, you can put whatever text you want. And this function is defined in another header file called stdio.h. Basically, that file has the code that implements the print function so that you don't have to do it on your own. Just do print this and it will show up on your monitor. So it allows you to include this predefined function that are pre-built already, like standard IO stdio.h or standard library stdlib.h. These are really, really useful going forward. You can also use this for install library. For example, like the Boost library is used quite a lot in C++ for certain data structure. I can use that in as a part of a header file. I'll show you the example soon. Let me wrap this up. The last thing I want to tell you is printf and scanf. Printf prints something on your monitor. Scanf take something from your keyboard. All right. So we can do printf inside quotation. That's a text you want to print. If you use percent means that it's a special character. That means I will take whatever value here and print that in certain format. We call this the format string. %d means decimal number. %s, for example, is text, string. %c is a character. Right? So you can use like %d, %f, %f is for floating point. %x is hexadecimal, right? So you can print different formats of the same value. To read from the standard input, you can use scanf. The only difference is over here, it represents the type of the text that you're putting in. %d means that you're about to read a number from the keyboard. Then you put the result into the variable that come right after. One quick thing for this variable, put ampersand in front of it. We'll learn more about why ampersand in 2 weeks. For now, just remember you have a variable declare. If you want to scan F, use ampersand in front of the variable name. Basically, when you have ampersand in front, it means the location of the variable. Scanf take the location of the variable, the location, literally the location in your memory. It doesn't take the variable name, it takes where is that location. So it can write that data into the location. You want to practice with the format string in our in-class exercise. So we want to kind of finish earlier so that you can do the assignment. Quick thing on assignment 1, there's a correction for invite.sh. Basically, just make sure your script invite anyone older than 18 years old. Then it's an in-class exercise. Please go to Canvas. The first thing we want to do is make sure you can compile C code by testing if GCC is installed or not.